Alrighty, Coach Goo back again with another fun-filled, action-packed, flipped, oh wait, just kidding, not flipped, Algebra 2 classroom video. Totally in the habit of saying that. Today, we're getting into the fun stuff, the quick and easy note section of evaluating functions. This is where it's at. This is the fun part, guys. Here we go. First thing we need to look at, we need to know a few terms here. Remember, the input for a function, look right here, the input is x, okay? X is the input. The output is f of x. We've usually seen the output as y, but when we're talking about functions, it's going to be f of x. That is a fancy f right there. So, y is pretty much the same thing as f of x. X is the input, f of x is the output. So, taking a look at this, what is the output for the given input? They're telling us that the function rule right here is f of x equals negative 2x plus 5. So that's the function rule, and they're telling us what the input is. So if the function rule, check this out, if the function rule is f of x equals negative 2x plus 5, they're asking us, what is f of x when x, the input, is negative 3? What is it when x is 0? What is it when x is 1/4? So let's find out then. So when x is negative 3, all we're going to do is put like this. F of negative 3 equals negative, wow, this is perfect because look at number 1. The question asks you, what does f of negative 3 mean? Well, it means exactly this. It means f of negative 3 equals negative 2 times negative 3 plus 5. It pretty much means when you substitute all the x's with that negative 3. So now we're just going to solve for this. F of negative 3 is going to equal negative 2 times negative 3 is positive 6 plus 5, which equals 11. So f of negative 3 equals 11. That's my answer. Circle it so I can see it. Boom. There it is. F of x, the output is 11. So you guys try the next two, 0 and 1/4. And number 3, we're going to state the domain and range of f of x. We can see that our rule is negative 2x plus 5. That is f of x, right? Now, if I were to graph this, this is an equation of a line. It's an equation of a line that crosses at positive 5. And then it just goes down 2 over 1 forever. Down 2 over 1, down 2 over 1. So it's pretty much a line that goes on forever like this. So what would the domain be? The domain, I'm just going to write D here, is going to be negative infinity to positive infinity because it's going on forever in both directions. What about the range? The range is the same thing. It's going from, it can go down forever, it's going up forever. So negative infinity to positive infinity. Alrighty, moving on. Now look at this. Sometimes you'll see questions like this where they tell you two different functions, g of x and h of x. They've told you what each of those stand for, so let's evaluate a few. Look at number 1. It says, what is g of 0? Well, which one of these functions is the g function? That is this one right here that says 3 minus 4x. So we're gonna take this one. G of 0 equals 3 minus 4, and we're going to substitute 0 in for that x, so 4 times 0. So now what's that? That's 3 minus 0 because 4 times 0 is 0. Now 3 minus 0 equals 3, so my answer is 3. Circle that. Boom. G of 0 equals 3. Now this is where you have to pay attention. Look over at number 3. It says h of 17. We're not looking at the g function anymore. Now we're looking at this h function. So then h function equals 10x. So instead of x, I'm going to write 17 because they asked for h of 17. Okay, what is 10 times 17, guys? I know you know the answer. It is 170. Good job, everybody. 170. The answer, h of 17, equals 170. So circle that. Boom, done. Now check out number 5. Whoa, 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 whoa. This one has 2 combined in 1. So we're going to take g of negative 2. So we're going to find the answer of g of negative 2. G of negative 2 is going to be 3 minus 4 times negative 2. Let's solve that. What's 4 times negative 2? That is negative 8. So now we've got 3 minus negative 8. If I subtract that negative, it's like I'm adding. That's going to be 11. So that's going to be 11. All right, so that's the g. Now let's do the h function. They want h of 2. So h of 2, that's h is 10 times 2. What's 10 times 2, guys? That's 20. And what do they want us to do with these functions? They wanted us to add them together. So we're just going to add, see this plus sign right here? We're going to add 11 plus 20. So the final answer is going to be 31. There it is. Boom. Done. Number 5, wait a second. Wait a second. This one looks really weird because what the heck is a? It's just a letter. It's just a variable. Don't worry. You can still do this problem just the same as always. The h function we're looking at is 10 times x. Instead of x, we're using a plus 3. So look, we're going to have h of a plus 3 equals 10 times, instead of x, I'm writing this a plus 3. So a plus 3. So all I have to do here is distribute 10 times a and 10 times 3. What is 10 times a? That's going to be 10a. And then what is 10 times 3? That's 30. So my final answer here is 10a plus 30. H of a plus 3 equals 10a plus 30. There it is. Oh my goodness. I'm so good at this. Now let's move it down a little bit, all the way down to these ones. Connecting function notation to domain and range. Okay, so look at number 1. We're finding the range of the function f of x equals x plus 6 when the domain is the set of -2, 0, and 14. They specifically told us that the domain is only these 3 numbers. So if we're looking for the range, we're going to use these domains, these inputs into the function, find each answer, and that would be the range. So check this out. F of x, so let's do -2 first. So f of -2. Remember, the domain is the x value. So f of -2 equals -2 plus 6, because we're substituting this -2 into that x right there. All right, so -2 plus 6 equals +4. So next up, now we're going to take care of this 0. F of 0 equals 0 plus 6. What's 0 plus 6? That's going to equal 6. And then finally, we've got f of 14 equals 14 plus 6. We substituted each of these domain values into that x. What's 14 plus 6? That is 20. So we've checked all the inputs and saw what outputs we got. That would be 4, 6, and 20. So that is my range. So my range, I'm going to write it right here, range R is going to be, I'm going to use a bracket, guys. It's a set. It's going to be 4, 6, and 20. There it is. That's my range. Perfect. Now the last thing we need to know how to do is this. Look at number 3 right here. This time we're not looking for the range. We are looking for the domain. Oh my goodness, we're going backwards. They told us the range, 9 and 17. Remember, the range is the output, and the output is f of x. So instead of plugging this into the x part, we're going to put this into the f of x. We're going to substitute that in for f of x. So watch, it's going to be like this. First, my range is 9, right? So I'm going to put 9 equals x squared, because f of x is my output. The range is my output, so I'm going to plug this 9 into the f of x spots, okay? So now we need to solve for x. That's what we're doing here. So how am I going to get rid of the squared thing off of the x? We're going to take the square root of both sides. Boom, boom. Now the square root of 9, it could be 3, but it can also be -3. So plus and minus 3 equals x. So now I found 2 answers right there. That's +3 and that's -3. Okay. All right, next let's take care of the 17. So let's substitute the 17 in for f of x. So 17 equals x squared. The same thing. We're going to take the square root on both sides to get rid of the squared. Boom. And that means that the square plus or minus the square root of 17 equals x. See, 17 is already prime, so we can't actually find an answer for that. So we are just going to put the square root of 17 and then put the plus and minus in front of it. And so that means my domain now, what is my domain? It's going to be the set of plus and minus 3 and comma plus and minus the square root of 17, and that is my domain. So when they're asking for a domain, we're kind of working backwards. When they're asking for range, we're working it like we normally would, substituting the x. So that, my friends, is the end of the evaluating functions notes. Oh my goodness, that was so fun. So see you in the next one. Peace.